Hello! A little while ago, I made a 3D printer in Roblox, and that made me wonder, what would a CNC machine in Roblox look like? Functionally, they're both very similar. They even read the same files. So I figured, why not try and make one? I mean, how hard could it possibly be, right? Here's one of the first working versions using a sample model from Fusion 360. It looks pretty cool, but it's not very good, and it's super slow. This clip you're watching right now took 5 hours and 41 minutes to film. But undeterred, I took another shot at it. Roll the montage. It looks better, but it's definitely not perfect. So what went wrong? Just a warning, this next part gets pretty dry, so if you want to protect your sanity, I recommend skipping it. The first issue I ran into is, originally, I never had to write code to run codes G2 or G3, which are G-code for clockwise and counterclockwise rotation, respectively. Which means now I have to calculate arcs, which takes math. I hate math, I'm terrible at it, so I needed an alternative. Firstly, I did what any self-respecting programmer would do. Find open source software to learn from, of course. But if you've ever tried to read someone else's code, you'll know that it takes years off your life. So I quickly gave up on that. I did, however, learn some important things about drawing arcs, which gave me an idea. The C-frame data type in Roblox holds both a vector position in 3D space as well as rotation. The first step is you need to find the center of your arc. You start at the first set of coordinates and add your offset, which in G-code is the IJK coordinates. Step 2, you use the arc center as the origin point of your C-frame. Now the cool part of using C-frames is that if you give it 2 sets of coordinates, it'll rotate itself so that its negate Z coordinate faces the second set of coordinates. Why is this useful? Well, no matter how you rotate the C-frame, you can add the radius of your arc to the Z component of your C-frame, and you'll always have a point on the edge of your arc, where you can now place a block. Here's an example of how that looks. This is an example of what we call a Hacky Fix. It works most of the time. Sometimes it goes off and does its own thing, like here. Why? I don't know. The proper solution is to use the midpoint circle algorithm, which is exactly how a real CNC machine draws arcs. But since I'm incredibly lazy, I decided to try skipping this entirely, which actually ended up working fine. And here's one more thing that went wrong. If you look closely, you can see these gaps between the generated blocks along the arc, which looks fine for generative design, but it doesn't work so good for subtracting blocks. To give the CNC machining effect, I use the block subtraction part of Roblox's modeling API, which effectively cuts away a shape from another block. Since there were these gaps here, they were left in the end product. Which leads us to problem number 3. The modeling API is so painfully slow. Every time you add or subtract blocks, you have to wait for the program to calculate and draw the end result. For complex shapes, this seems to leave the artifacting that you see. Interestingly, if you have a file that takes several days to complete, it gives some really odd warping. I'd show you, but I ran out of hard drive space and accidentally deleted the footage. There are definitely a few ways I could still optimize this. My original plans were to make a 4 and 5 axis CNC machine, but if the results aren't great, I don't see a point. I'll leave you with this small print, and I'll put a link to the game in the description if you want to watch it in real time, but I really don't get why you would want to. Thanks for watching. If you have any suggestions or want to tell me everything I did wrong, feel free to leave a comment. Bye!